Welcome to DEEKSHA Concept-Based Digital Learning. I am P.Usharani, lecturer in Mathematics, TSWREIS-GNANA. Now we are going to learn rank of a matrix and solutions of system of linear equations, which play an important role in the concept of linear algebra and also our day-to-day life. Before discussing our topic, let me explain brief history of matrix theory. The term matrix was invented by Sylvester. And matrix operations were invented by such as addition of two matrices, subtraction of two matrices, multiplication of two matrices are invented by Arthur Collins. And determinants of a matrix was invented by Gauss. Rank of a matrix was used first time a mathematician Frobenius. And solutions of system of linear equations are invented by mathematicians Cramer, Gauss and Jordan. This is brief history of matrix theory. Now let's come our topic rank of a matrix. Let me explain definition of a rank of a matrix. Formal definition is the highest order of non-zero minor of a matrix is called rank of a matrix. And it is denoted by row of A. Suppose if you take matrix as A, it is denoted by row of A. Sometimes we can notate like this, rank of A. Okay, let me explain some examples. I will take A as 1, 2 by 2 matrix, that is 1, 2, 3, 4. Order is 2 by 2. Now what does it mean here? The highest order of non-zero minor of a matrix is called rank. Minor is nothing but determinant of a matrix. Now find determinant of this matrix. This is determinant of 1, 2, 3, 4. It will be 4 minus 6. It is minus 2. It is non-zero. What is the order of this minor 2? Why? Because order of this matrix is 2 by 2. So, rank of this matrix A is 2 according to our definition. Let me explain one more example. A equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 3 by 3 square matrix. According to definition, now find determinant of A. So as we know how to find determinant of A, take any row or column of the matrix. Here I am taking row, first row, 1 into cut this column at this row. The determinant of submatrix 5, 6, 8, 9 is 5 9s are 45, minus 48 minus 2 into, again submatrix is here 4, 6, 7, 9. Determinant of that submatrix is 4 9s are 36 minus 6 7s are 42 plus 3. And determinant of this submatrix is here 4 8s are 40, 4 8s are 32 minus 7 5s are 35. Now simplify. If you simplify this one, it will be 0. Determinant of A is equal to 0. So what is our definition? The highest order of non-zero minor of a matrix is called non-zero. So but here we got 0. Again we have to search for non-zero minor. Now we can take another submatrix here, that is 2 by 2 matrix. In this I will take one submatrix like this. Now let us see one submatrix determinant, that is 5, 6, 8, 9. Now what is it? Determinant of this submatrix is 9 5s are 45 minus 48. It is minus 3. So not equal to 0. Here it is non-zero minor, which is order 2. So rank of A equals to 2. Like this we have to find rank of A. Let me explain one more example. Suppose A is given as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Observe this matrix, it is a 4 by 4 matrix. To find the rank of this matrix, we need to find determinant of the matrix. So it is very difficult to find a higher order matrices determinant. Why? Because suppose, let me show you how to find determinant of A here. Now we can choose any one row or column. I am choosing this row. So if you choose that row, now to get determinant 1 into, what is submatrix of 1? 6, 7, 8, 10, 11, 12, 14, 15, 16. We need to get this determinant 6, 7, 8, 10, 11, 12, 14, 15, 16 minus 2. Minor of these 2 is, observe this 2, cut this column and cut this row. What is remaining submatrix? 5, 7, 8, 9, 11, 12, 13, 15, 16 plus 3. Right, minor of 3, cut this column, cut this row. Remaining submatrix here 5, 6, 8, 9, 11, 12, 13, 15, 16. And last term 4. Minus 4. What is submatrix of minus 4? Cut this column, cut this row. Remaining 5, 6, 7, 9, 11, 12, 13, 14, 15. So it is very difficult to find this determinant. That's why very good method was invented, that is echelon form of a matrix. By using that echelon form of a matrix, easily we can find rank of a matrix. Let us see echelon method to find rank of a matrix. Echelon form. Let me explain what is echelon form. Echelon form is nothing but, suppose I have a matrix like this, A11, A12, A13, A21, A22, A23, A31, A32, A33. By using row transformations, as we know row transformations, apply here elementary row transformations. Then this matrix will be converted like this. First row, first element 1, then A12 becomes B12, some changed value. A13 becomes B13. In this place 0 will come. In second row, second element again 1. Second row, third element becomes as B23 suppose. And third row, first element again with 0. Second element also 0. Third element is 1. This form is called echelon form of A. If you treat this matrix as A, this form is called echelon form of A. So after converting this matrix into echelon form, now we can count number of non-zero rows. This is row 1, this is row 2, this is row 3. How many number of non-zero rows in this echelon form? 1, 2, 3. Suppose if you get like this, here we have number of non-zero rows in this example 3. So rank of A equals to number of non-zero rows, number of non-zero rows in the echelon form of A. So according to our example here, rank of A equals to how many number of non-zero rows? 3. Let me explain one example by using echelon form. Let A equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. Our question is find rank of A. Find rank of A. So here I am applying echelon form. Let me convert this matrix into echelon form. So echelon form is nothing but we have to convert the given matrix into upper triangular form. By using row elementary transformations. Okay. See what is given matrix here? A equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, very first we get mark principal diagonal. in this matrix. This is principal diagonal for this matrix. If I make these three elements as zeros, automatically it will be converted into upper triangular matrix. For that, I will use row 1 and row 2. In first step, I will use row 1 to make this 4 as 0. You treat this one as R1, this one as R2, this one as R3. So what we have to do here? In second row, fourth element we have to make as 0. So change in R2, write transformation like R2 implies when it is 0, by using R1, 4 times of R1 here, R2 minus 4 R1. If you do this transformation, this value will be 0. And at the same time, apply transformation for R3 also. Here in R3, first element is 7. Use R1 to make that one as 0. R3 minus 7 times of R1. So if you apply these two transformations for this matrix, that matrix will be changed like this. Change in matrix. No change in first row. 1, 2, 3. Change in second row. 4 minus 4. 0. 5 minus 8. Minus 3. 6 minus 12. Minus 6. Next, R3 minus 7 R1. 7 minus 7. 0. 8 minus 14. Minus 6. 9 minus 21. Minus 12. We get like this. Now observe here, again mark the principal diagonal like this. You observe here, we got two elements as zeros and we need to make this element also as 0 by using this R. Now write the transformation here. Change in R3. That's why I am writing R3 first. R3. So for R3, minus 6. When it is 0, R3 minus of 2 into R2. Apply R2. Minus 6 plus 6, then it will be 0. Like this, we can choose the transformation. Now, change in matrix will be 1, 2, 3, 0, minus 3, minus 6, 0. Here it will be 0. Apply transformation for our row 3. Minus 6 plus 6, 0. Minus 12 plus 12, 0. Observe this form. Again you draw the principal diagonal like this. After applying each and every element of elementary operation, you check the principal diagonal and below the elements. So in this form, below the principal diagonal elements all are zeros, no? For this, I will construct one triangle shape here. See. So we got upper triangular matrix. Now it is indirectly in the echelon form. It is echelon form. Of A. So according to our condition, number of non-zero rows in the echelon form is called rank of A. Observe this matrix, how many number of non-zero rows here? First row is non-zero row, second row is non-zero row, third row, it is not a non-zero row, it is 0 row. So how many non-zero rows? 2. Then rank of A equals to 2. Like this, we can find rank of a matrix by using echelon form. It is very easy method to find the rank of any matrix, not only square matrices, we can find the rank of a rectangular matrix. Now, let us see some properties of a rank of a matrix. Suppose A is a order of n by n matrix and non-singular. then rank of A equals to n. If above A is singular, a rank of A less than n. Why here? If it is non-singular, that what does it mean? Determinant of A not equal to 0. So according to basic definition, that A not equal to 0, rank of A is order of this A. That is here. If A is non-singular, in this case, determinant of A is equal to 0. So automatically we can go for minus, sub minus. So automatically that rank of A less than n. Now, rank of 0 matrix is always 0. What is 0 matrix? It looks like 0, 0. Suppose I am taking 3 by 3. It will be like this is 0 matrix of order. Rank of identity matrix of 2. What happens here? Identity matrix of 2 is 2. Why? What is I2? 1, 0, 0, 1. It is by default in the echelon form. Looks like upper triangle. So, number of non-zeros 1, 2. Rank of I2 is 2. For the generalization, rank of In equals to n. Next property, rank of suppose I am taking two square matrices of same order. I want to find rank of A plus B, that is less than or equals to rank of A plus rank of B. Next I will take subtraction of two matrices. It is greater than or equals to rank of A minus rank of B. Suppose if I take rank of A of order m by n, which is rectangular matrix, it is less than or equals to minimum of m comma n. M indicates number of rows of A, n indicates number of columns of A. Now let us see some important applications of rank of a matrix. So very good important application we have, that is to check consistency of a system of linear equation. Consistency, what does it mean? Having solution. Now let us check consistency of the system of linear equations. First of all, let me explain system of linear equations. Suppose I have this system a11x1 plus a12x2 plus a13x3 equals to b1. a21x1 plus a22x2 plus a23x3 equals to b2. a31x1 plus a32x2 plus a33x3 equals to b3. Now we can convert this system of linear equation into matrix equation. How we convert? See, we can convert like this. Ax is equal to b form, whereas A called coefficient matrix. X is called variable matrix. B is called constant matrix. Now let us write coefficient matrix. You write variables of coefficients in first row, that is A11, A12, A13. Second row coefficients A21, A22, A23. Third row coefficients A31, A32, A33. This is a variable matrix. How many variables here? 3. Those are x1, x2, x3. This is called variable matrix. This is equal constant values b1, b2, b3. Like this, we can convert the given system into Ax is equal to b form. Now, here we can get two types of systems again. One is homogeneous system. Let us take non-homogeneous system first. Non-homogeneous system. Second one is homogeneous system. Our matrix system equation is Ax is equal to B. If B not equal to 0, that system is called non-homogeneous system. If B is equal to 0, this system is called homogeneous system. It looks like Ax is equal to 0. It looks like Ax is equal to B. Why? Because B is not equal to 0. Now, let me explain consistency of the homogeneous and non-homogeneous systems by using rank of a matrix. Now, our system is here Ax is equal to B. In this case, very first we have to find rank of augmented matrix. What is augmented matrix? When you write A, B like this, A matrix and B matrix. See in this our system, A matrix is A11, A12, A13, A21, A23, sorry, 22, A23, A31, A32, A33. Put a dotted line to write B. What is our constant matrix? B. You write B1, B2, B3. It is called augmented matrix AB. Now here we have to find rank of AB and rank of A. If rank of AB is equal rank of A, we can say that system is consistent. System is consistent. That means system has solution. Has solution. If it has solution, again it has two types of solution. One is unique. Another one is infinite many solutions. When we get unique solution, if rank of A is equal rank of AB is equal number of unknowns. Number of unknowns or variables. Number of variables. According to our system, how many number of variables here? We have 1, 2, 3. So 3 here. Then in this situation, this system has unique solution. Otherwise, if rank of A is equal rank of AB less than number of unknowns, then this system has infinite many solutions. When it is inconsistent meaning is nothing but the system has no solution. It is inconsistent when rank of A is not equal to rank of augmented matrix AB. So when the non-homogeneous system is inconsistent, if rank of A not equals to rank of AB. Now let us discuss homogeneous system consistency. Homogeneous system, if you observe the homogeneous system here P is equal to 0. So no need to find augmented matrix. Why? Because in augmented matrix B is 0. So we need to find rank of A only. So this system is always consistent. First step, it is always consistent. If it is consistent, again this system has two types of solutions. One is trivial solution. Another one is non-trivial solution. So when we get trivial solution, depends upon rank again. Rank of A is equal to number of unknowns or number of variables. When we get non-trivial solution, rank of A less than number of unknowns. So we should keep these formulae, these conditions in our mind. Then easily we can check the consistency of the system. Let us see one example on solutions of system of linear equations. x1 plus 2x2 plus 3x3 equals to 1. 4x1 plus 5x2 plus 6x3 is equal to 2. 7x1 plus 8x2 plus 9x3 equals to 3. Solve the system. So we can solve the system by using Gauss elimination method. In Gauss elimination method, very first step we can convert the given matrix into echelon form and we can check the consistency of the system. If it is consistent, we can find whether it is having unique solution or infinite many solution. Why? Because our given system is homogeneous, non-homogeneous system. That's why we can get, first of all, we have to check consistency. If it is consistent, then we have to check which solution it is having, unique or infinite many solutions. For that, I will find the rank of augmented matrix. What is augmented matrix for this system? 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a dotted line, write B, 1, 2, 3. Now, we have to convert this matrix into upper triangular matrix by using row transformation. For that, I will mark principal diagonal. Here, we have to make these three elements as zeros by applying row transformations. In first step, by using R1, this is R1, this is R2, this is R3. By using R1, I can make this R2 element and this R3 element as zeros. R2 element becomes 0 when we apply this transformation. R2 minus 4 R1 R3 element becomes 0 when we apply this transformation, that is R3 minus 7 R1. Now change in matrix will be no change in first row 1, 2, 3, 1. Change in second row 4 minus 4 0, 5 minus 8 minus 3, 6 minus 9 minus 6 minus 12, that is minus 6, 2 minus 4 minus 2. Now come to R3, 7 minus 7 0, 8 minus 14 minus 6, 9 minus 21 minus 12, 3 minus 7, that is minus 4. Again you check principal diagonal below elements whether those are zeros or not. So one element is non-zero element is here. We have to make that element also as 0 by using R2. Now when it is 0, R3 minus 2 into R2. Then change in matrix will be no change in first two rows. 0, minus 3, minus 6, minus 2. Now change in third row. This is 0. We are using R2, 0. Here we get 0. Here also we get 0. Here also we get 0. Completely we got here non-zero row. Now we can check rank of AB, that is augmented matrix. While observing the rank of AB, we can observe the complete matrix rank. How many number of non-zero rows in this echelon form? 2, 1 and 2. So rank of AB is 2. At the same time, we can get rank of A also. To get rank of A, you observe only matrix A. How many non-zero rows in this echelon form? 1, 2. So rank of A is 2. And number of variables are 3. Now check the consistency. Rank of AB augmented matrix is equal rank of A is equal number of unknowns. By this what we can conclude? This system has unique? No. It is less than number of unknowns. This system has infinite many solutions. It has infinite many solutions. Now let us find infinite many solutions for this system. To get solution, we can take change in matrix A, variable matrix X is equal to change in matrix B, like this. What we get in echelon form, we can write here. So what is our change in matrix A? 1, 2, 3, 0, minus 3, minus 6, 0, 0, 0. And write variable matrix here, that is x1, x2, x3 is equal to change in constant matrix is 1, minus 2, 0, 1, minus 2, 0. Now write equations. First equation is x1 plus 2x2 plus 3x3 equals to 1. Second equation is minus 3x2 minus 6x3 equals to minus 2. So here we cannot write the third equation. Now we need to get solution. So in this situation we have two equations and three variables. That's why we need to get one free variable here. So for every problem, when you get infinite many solutions, there some free variables will be existed. How we get those free variables? Number of free variables equals to number of unknowns minus rank of A. So in this system, number of unknowns are 3, x1, x2, x3. Rank of A is 2. So 3 minus 2, we get one free variable. So among these three, we can take one free variable. That is, I am taking here x3 as free variable and let x3 equals to k. Now substitute x3 equals to k in the above equation. Give numbers for these equations 1 and 2. If you substitute x3 is equal to k in equation 2, x2 becomes minus 2k. If you substitute x3 and x2 in equation 1, x1 becomes minus 2, x2 minus 3, x3 and plus 1 is here. 4k minus 3k plus 1. So x1 equals to k plus 1. Now our infinite many solution will get like this. K plus 1, x1 is k plus 1, x2 is minus 2k, x3 is k. This is solution for the system. So this is about solutions of system of linear equations. Thank you for giving this opportunity.